Hello, today I'm going to be recording a video on random variables. So, random variables is all about probability. We've all come across probability, so when rolling a die, the outcomes are from 1 to 6, and each of these outcomes they are equally likely. So we can have different events. If you say that A1 is an event of getting an odd number, B event could be getting an outcome of an even number, so odd and then even, and you can have another event for outcome 6. So you can represent that as a you can whenever you get different outcomes, you can put these into the different events. So there are a specific definition that we need to know. We have union, the probability of A or B occurring. So A or B. So a union for event A or B. So we had A was odd and B is even. So getting A or B, that is equal to 1. That's 100%. What about getting the probability of getting A or getting a 6? So probability of A was an odd number and getting a 6. So A or event of getting a 6. So you need to add these probabilities together. So that is half plus 1 over 6, and that is equal to 2 over 3. We also need to know intersection. The probability of A or B occurring at the same time. So intersection, if you have intersection of event A with B, that would equal to 0, because both of them can't happen at the same time. Getting an even and odd number, there's no number like that. That would equal to 0. What about probability of event B, which was even number, intersect with getting a 6? So what would the probability of that be? That would be 1 over 6. So it's basically the event of 6. So we have disjoint and mutually exclusive. Two events don't occur at the same time. And we have independent. So the events, they don't affect each other. Now we're going to look at joint probability. So you have event A and B happening at the same time. That is joint probability. And then you have marginal probability. So marginal probability, if you have two events and they both link with each other, so probability of A links with probability of B, and probability of A2 links with probability of B2 and B1, you want to find the marginal probability. And that is, you need to add up the probabilities. So if you want to find out the probability of B1, you will need to add the probabilities of probability of A intersect with B1 plus probability of A2 intersect with B1 plus probability of A3 intersect with B1, and do that up to J. That way you will get the probability of B1. So that is marginal probability. We also have conditional probability. So if one event occurs, how does that affect the probability of another event? So you have in a cup, you have a ball and a square, a cube. So you have 3 balls and 2 cups. So if you pick the ball, that will reduce. So if I told you we had 3 balls and 2 squares in a cup, and you take 1 ball, you will get 2 balls remaining and 2 squares. So what would the probability of getting another ball equal? That would be 2 out of the total, which is 4. 2 out of 4. So there are some formulas that you need to know how to get this conditional probability. Bayes' rule. So what is Bayes' rule? We need to learn the formula. You need to learn the formula. So it's probability of B given that A occurred, that is equal to probability of A occurring given that B has occurred times by the probability of B divided by probability of A. Statistical independence. A has no relationship with B. So if B has no relationship with A, it doesn't matter if A happens. That will not affect B occurring. So you can write that as a formula. Okay, let's get to random variables. Function that assigns a real number to each outcome. If you toss a coin 3 times, you will get heads. Maybe once, maybe 0 times, 1, 2 times, 3 times. You'll never get 4 times if you toss a coin 3 times. So, what is the probability, the best probability that you can figure out for getting 0 heads? What is the best probability you can get for getting heads once out of the 3 times. So what I mean by best is if you do it 1,000 times, so you record how many heads you get. If you do it like 1,000 times, you toss a coin 3 times and then you record how many heads you get. You do 1,000 times. Well, you can work that out, that for if you do it that many times and you'll get 0 heads. If you do it 3 times, how many times that happens? That's 1 out of 8. If you get 1 head, that's 3 out of 8. If you get hit 2 times, that's 3 out of 8. And if you get hit 3 times, so that is very unlikely. So it's same. It's 1 out of 8. So that is just an example of random variables. So you just assigned a real number to each outcome. Another example, you have 2 dice, you roll them, and X represents the sum of the values. So now we're going to use this information to work out this question. So when you roll these 2 dice and you see that the sum was odd, what is the probability that the sum is less than 8? So we already know that you roll the dice and you get X is odd. So if this has occurred, now how does that affect the probability of now it being the outcome being less than 8? So this is a conditional probability, so you have to use the formula. And so the probability that is less than 8 and the outcome is odd over the probability that X is odd. So the top part is you have to add these outcomes. Probability that the outcome is a 3, probability that the outcome is a 5, plus the probability that the outcome is a 7, divided by the probability that X is odd, and that is obviously half. And the answer is 2 over 3. So that is random variables. With random variables, you have distribution functions. So distribution functions. So you have fx is equal to, that's the distribution function, that is equal to probability that large X is less than or equal to small x. So large X represents the outcome and the little x is what you get. So capital X could be the number of heads, so, and the little x could be what you got. So like if you get 3, and the little one could be 2. So the properties, so the probability that the capital X is between these little x1, x2. So that is the probability you can work that out. The distribution function x2 minus the distribution function of x1, and probability that capital X is greater than smaller x, that is equal to 1 minus distribution function. So describing a random variable by few characteristic numbers or summary measures that are representative of its PMF. So PMF is probability mass function. So we are describing a random variable by few characteristic numbers or summary measures that are representative of its PMF. So we all know expectation. So expectation, we have you have a EX that's equal to, so we know that EX is like the mean, and to work out the mean you have to take the sum between I to n, sum of I to n, so xi times by the probability of getting xi. So you also can work out the variance of x, that's equal to expectation of x squared minus the mean squared. So tossing a coin, we can work out the mean. You already know the mean for tossing a coin. It's the probability of getting a half. It's half, so heads or tails, the probability is a half. So we can use this formula. So I is taking the sum between 1 to 2, that there's 2 outcomes, and from 1 to 2, so you do x1 times probability of getting an x1 plus x2 times by the probability of getting x2. So x1, let's just say that's 0, that's equal to so 0 times by half plus probability of getting a head, which is 1, so you do 1 probability of getting a head, that's a half, but we say that x2 is 1, so that's the mean would be 1, and you can also work out the variance. Correlation coefficient, so using the variance we can work out how related two variables are, and correlation coefficient equation is a joint standard deviation between x and y over the square root of variance x times by the square root of variance y. So if the correlation coefficient, if it's 0, then x and y are uncorrelated, and if the correlation coefficient is equal to 1, then they are fully correlated. Then we just looked at expected value. You can also work out the conditional expected value. So here's an example. If a die is rolled, event A, let's say, is an even number. Find the conditional expected value of x given that A occurred. So find the conditional expected value. So we have that we know the formula already. So A has occurred. If A has occurred, that means a 2, it could be a 2, it could be a 4, it could be a 6. So they have, one of them have occurred. So now you have to find the expected value of that. So find the conditional expected value of x given that A has occurred. So we use the formula, and we know the formula is so it's E x given A, that is equal to, so we have the first outcome, which is 2 times by the probability that A has occurred, and what is the probability that x will be 2, plus, so the outcome of 4, and you have to multiply that by probability of, given that A has occurred and the answer, the outcome was 4, plus if 6 has occurred, so the outcome 6, multiply by the probability that an even number, so we know that even, there was an even number, was a probability that x occurring. So you have to add these up, and the answer is 4. So there's a formula for this, and it's very useful. So I guess, right, these are just discrete. And there's another, if you have a graph, you can also work it out. So we're going to now look up the probability mass function of some random variable. So you have a probability mass function, you have it for a uniform. So the probabilities of these outcomes, they are all equal. So you have a die, you have a coin, and the probability mass function, so you have probability that capital X is equal to small x, that is equal to 1 over b minus a plus 1. So what is b, what is a? Well, these are the maximum values. So for a die, it will be 1 over 6 minus 1, so b minus a plus 1. So if you do 1 over 6 minus 1 plus 1, that will give you 1 over 6. So that is like the probability of, getting a 1 or 2 or 3 is 1 over 6. So that is the uniform probability mass function. You can work out the mean of it, you can work out the variance. So we have another PMF, Bernoulli. So Bernoulli, any experiment with only 2 possible outcomes. So you have a success or failure. So this is not like uniform. So probability that x equals to 1, that could be like success, and the probability of getting a success could be if you like pass your test could be 0.7, and probability of failure could be the opposite of that, 0.3. So the mean, you have to use the expectation formula and the variance as well. So the mean for Bernoulli PMF is P, and the variance is P times Q. So it's probability of success times by the probability of failure. So we've done 2 now, so binomial PMF. So for my understanding, binomial is just like the Bernoulli, but you do it n times and you find the probability of that. So there's a formula that you need to learn. So if you do an experiment n times, and what is the probability that you get k results that you want to get? So if you toss the coin 6 times and you say that let k equal to 2, so that means let k equal to 2, so 2 heads. So if you toss the coin 6 times, if k is equal to 2, that means what's the chances that you get 2 times heads? So the formula would be, so it's I'm not sure what that is called. So it's over here it's reversed. So it's like n and let me try to think what that is called. It's just like n and then this k on the bottom. You times it by probability of getting the outcome to the power of k times by 1 minus p. So 1 minus p is not getting the outcome over n minus k. I'm going to end in 2 minutes. Yeah, so here's an example of binomial. So tossing a coin 4 times, so n is equal to 4. So using this formula, you can actually work out the probability of getting 0 heads, 1 head, 2 head, 3 head, 4 head. And the mean for binomial is n times p, and variance is n times p times by 1 minus p. So 1 minus p is the probability of not getting the outcome that you expect. So Poisson PMF. This one's a bit tricky. Poisson PMF. So it's the probability of x equals k. So k is the outcomes that you want to get, and the probability to work the probability out, it's lambda to the power of k over k factorial times by e to the power of minus lambda. So lambda is the average. So Pascal So if you have considered identically independent Bernoulli trials, let X be the number of trials until Rth success. So until Rth success. So you do it a number of times. And so until Rth success. So there's a formula for that. K minus 1 and R minus 1. P to the power of R 1 minus times by 1 minus P to the power of K minus R. So Pascal, to better understand, we have a question. What is the probability that you get 3 heads after 5 flips exactly? So it's different. So you do 5 flips and you get 3 heads. So that is you have to do it 5 flips and you have to get 3 heads. And if you do as many times this and you get this many times, that is what this formula is about. You also have geometric. So it's the probability, it's like until the first success. So if you toss a coin, what is the probability that after 3 tosses you get a head? So you get 2 failures and then you get a head, you get a fail pass. So to work that out is probability P times by failure to the power of n minus 1. So n is the times you do it. So here you do it 3 times. So if you put in the formula, it's a half times failure, which is a half to the power of n minus 1, which is 3 minus 1, which is 2. So that is geometric. So we'll carry this on later. So let me just do a recap of what we've done so far. So we've looked at basic probability, union, intersection, disjoint, independent. We looked at joint probability, mutual, marginal probability, conditional. We looked at Bayes formula, and we looked at random variables, distribution functions, and expectation variance. And finally we looked at basic PMF models, so uniform, Bernoulli, binomial, Poisson, Pascal, and geometric. So thank you for listening. I hope you benefited.